Hey everybody, Calculus Lesson 9, this is still parametric, and I'm going to cover derivatives in the first video, and then I'll cover arc length in the second video, and try to go over some of the homework. So what we're starting out with here first is, how do you find derivative of parametric equations? So parametric equations are actually two separate functions. So I've got dx, I've got x that's an equation in terms of t, and I've got y that's a different equation in terms of t. So when I'm finding dx, I'm really finding dx dt and dy dt, and then I'm putting those together to find dy over dx, and the dt's cancel out. So we end up with dy dt. But x is still there. X is still where all of this came from. So we're finding, I think I said dx dt, we're finding dy dx, but it's still in terms of t. So when you look at this function, dy dt is the derivative of negative sine, and dx dt is the derivative of cosine. So dy dx is dy dt over dx dt, and then the dt's cancel out. So there's your function. So that is, so let's see, cosine over sine, so cotangent of t, and it asks us to evaluate this when t was pi over 3. So plug in pi over 3, negative cosine of pi over 3, negative sine of pi over 3, and then use some algebra to simplify all of that, and either of those answers would be okay. The second thing it said is find dy dx when at the point 1, 0. So my derivative equation is in terms of t, not in terms of x's and y's, but this point is an x and a y. So how am I going to evaluate something in terms of t when I don't have t? Well, then I got to find it. So when they told me that the x-coordinate is 1, they were telling me that cosine of t is equal to 1. So on your unit circle, when is the x-coordinate equal to 1? Well, that happens when y is 0. So, or when the angle is 0. So cosine of t is equal to 1 when t is 0. Same thing for the other one. When is the y-coordinate, negative sine of t, equal to 0? So what angles on the unit circle have 0 for a y-coordinate? Well, that would be 0 or pi or 2 pi. I mean, we could go on around the unit circle over and over. But so what value of t would give me both of those coordinates? Well, that happens when t is 0. So dy dx, plug in 0, you get negative 1 over 0. That's undefined. So at that point, the slope is undefined, which means that the function is vertical. The tangent line at that point, switch pages. The tangent line at that point would be a vertical line. On this one, they gave us a point again. So when is the x equation? When is cosine of t equal to 0? So we have an x-coordinate of 0 at pi over 2 or at 3 pi over 2. And when is the y-coordinate? So when is negative sine of t equal to negative 1? So that would be sine of t equals 1. When is the y-coordinate equal to positive 1? That's at pi over 2. So what is the solution? What is the value of t that gives me 0 for x and also gives me negative 1 for y? Well, that's when t is pi over 2. So plug in pi over 2, you get 0. So at the point 0, negative 1, this function is horizontal because a slope of 0 is a horizontal line. Okay, so what about second derivative? We talked about this in class today. This is not, the math here is not really hard to do, remembering what you're doing. Remembering that this is not just with functions, it was take the derivative of, to get the second derivative, do the derivative of the first. To get the fourth derivative, take the derivative of the third. This is, you do that, but that's not all. If I want the second derivative, I've got to do the derivative of the first divided by dx. If I want the third, I've got to do the derivative of the second divided by dx. So with parametric functions, you're always dividing by the derivative of x. So first derivative, derivative of negative sine over derivative of cosine. So we've got our derivative, dy dx is cotangent of t. So the second derivative is the derivative of cotangent, which is negative cosecant squared, over our original dx. So when you simplify that, one way you could simplify that is just 1 over sine cubed. Cosecant squared is 1 over sine squared, divided by another sine would be 1 over sine cubed. And then I'm not going to spend a lot of time on this. You plug in, you plug in pi over 3 for t, and then algebra gets you 8 over 3 root 3. When is x equal to 0 and y equal to negative 1? Well, that happens at t over 2, 90 degrees. So plug in 90 degrees or pi over 2, not t over 2. Plug in pi over 2 and simplify. On this one had more algebra in it. It's asking for slope and concavity, but these functions just had more algebra. dy, if you rewrite that as 1/2 t squared minus t, then the derivative would be 1/2 t minus 1. No, 2 times 1/2 is 1, not 1/2. So that would be t minus 1. So there's my dy. If you do dx, derivative of square root of t is 1/2 t to the negative 1/2. So here's all the algebra. That's really t minus 1 divided by 1 over 2 square root of t. So when you multiply by the reciprocal and then distribute, you get t times 2 square root of t. So that's t to the first power times t to the 1/2 power. Add the exponents, that's where 3/2 comes from. And then distribute the square root of t, 2 square root of t to the negative 1. So there's your first derivative. Okay, so now the second derivative is do the derivative of that one. So exponent times the number in front becomes 3. Subtract 1 from the exponent, so 3t to the 1/2. 1/2 times 2, and then subtract 1 from the exponent. So there's my derivative of dy dx over the original dx. So that's 3t to the 1/2 minus 1 over t to the 1/2 divided by 1 over 2 t to the 1/2. So when I multiply by the reciprocal, eventually, 1/2 plus 1/2 is 1, so that's 6t to the first power. And then the t to the 1/2 would cancel out, so that's where 6t minus 2 comes from. So there's your second derivative. So then it asks you to find that at the point 2, 4. Well, where is x, for what value of t do I get an x coordinate of 2? And also, for what value of t do I get a y coordinate of 4? Because it wants the x to be 2 and the y to be 4. So if I square, that gives me t equals 4. You can solve this, so that would be 8 equals t squared minus 2t. subtract 8 from both sides, and then solve that. And the solution that they have in common is t equals 4. So then plug in 4 to the first derivative, and that tells you the slope. Plug 4 into the second derivative, and that tells you the concavity. This is the same stuff. It's the same math. Well, the equation of the tangent line, maybe not quite so much. But we're doing the same math. They're just asking different questions. On this one, they're asking, where is the curve horizontal? So if it's horizontal, that means that its slope is equal to 0. So that means dy dx equals 0. Well, how do you divide two numbers and get 0? Well, that's when you have 0 on top, but not on bottom. So really all I needed to solve here was, where is dy equal to 0? So divide by 2. What points on the unit circle have a y-coordinate of 0? So that would be 0, pi, 2 pi, 3 pi, 4 pi, blah, blah, blah. This next one, where is it vertical? So that's asking, where is dy dx undefined? So how do you get undefined? You have a number on top and you have 0 on bottom. So really all I need to worry about is, where is dx equal to 0? Because that would give me 0 on bottom. That would be undefined. So there's dx, there's equal to 0. What angles on the unit circle have an x-coordinate of 1/2? That's positive 1/2. So that would be in quadrant 1 and quadrant 4. So pi over 3, 5 pi over 3. And then if you keep going around the circle, 7 pi over 3, 11 pi over 3, sorry, had to add for a second there, and for some reason that took a minute. But those are the things that they were looking for. The part on this that looks the worst is writing the equation of the tangent line, and this is something that you guys are going to be expected to do for sure. So what's the equation of the tangent line at t equals pi over 4? So the easiest way to write an equation of a line in calculus, in algebra it's y equals mx plus b, but in calculus it's the point slope form. Y minus the y coordinate equals m times x minus the x coordinate. So if I need the y coordinate, then I need to plug pi over 4 into the y equation. And when you plug pi over 4 into the y equation, you get 2 minus 2 times root 2 over 2. And then the 2's cancel out, so you get 2 minus root 2. There's y minus my y coordinate. I need x minus the x coordinate, so I plug pi over 4 into the x equation. And I get pi over 4 minus 2 times, sine of pi over 4 is root 2 over 2. And that simplifies to pi over 4 minus root 2. Here is x minus my x coordinate. So the part that's left is find the slope. Slope is derivative, so dy over dx, and then plug in pi over 4. So here is 2 times sine of pi over 4 over 1 minus 2 times cosine, making sure I got the derivative right, cosine of pi over 4. So algebra. The 2's here would cancel out, so that's root 2 divided by 1 minus root 2. And so I just left it square root of 2 divided by 1 minus root 2. There's some other things, some other different ways you could write that if you wanted to, but that is my derivative, that is my slope, and as messy as that equation in blue looks, it's a correct equation. That is an equation of the tangent line for that function at the point t equals pi over 4. Okay, next one is going to cover arc length and some of the homework, so if you need help with that, watch the next video.